Since I'm not with you guys today, I thought I would make a short video about how to do a new type of problem called combustion analysis problems. This isn't a real horribly difficult thing, but it's got a lot of different pieces to this problem and it can look a little bit complicated. So first of all, here's what the problem looks like. A compound contains only carbon, hydrogen, and oxygen. Combustion of 1.068 grams of the compound produces 1.601 grams of CO2 and 0.437 grams of water. The molar mass of the compound is 176.1 grams per mole. What's the empirical and molecular formula of the compound? Now this is something totally different than anything you've done before, but like all empirical formula problems, the real root of this is that you need to know the masses of the carbon, the hydrogen, and the oxygen in that original compound. That's really the key piece. And you can actually do that by dealing with the CO2 that was made during combustion and with the amount of water. Okay, so I'm going to walk you through that with a little video of me talking at the board here in just a minute. Okay, but next I want to show you a little bit about what this little chamber might look like where they would actually do this sort of experiment. Okay, what you would do is you have this heating area over there on the far left. You'd put whatever sample that you wanted to burn was, so it's going to be something that's easily combustible. And then you have two chambers a little farther down, one that absorbs water and one that absorbs the CO2 gas. So you put your weighed massed amount of your sample in the far left chamber, you heat it up, you run extra oxygen into it, and then all of the water that's made during the combustion and all of the CO2 that's made during the combustion is caught by those two little chambers over there on the right hand side. One grabs the water, one grabs the CO2. And the change in mass will tell you how much each of those grabbed. So you have a quantitative amount of water and carbon dioxide that you grab. Okay, so let's try this. If I took all the stuff that's in that problem and separated it all out and organized it, this is the stuff that you're burning. It weighs 1.068 grams. After it's burned, you have 1.60 grams of carbon and 0.437 grams of water. Okay, now the thing to remember here is all of the carbon that is here used to be there. All of the hydrogen that's here used to be here. Now to find the empirical formula of anything, what do you have to know? Well, you have to know the number of grams of carbon, the number of grams of hydrogen, and the number of grams of oxygen in this compound. Convert it to moles, divide by smallest, make sure you have whole numbers, multiply to a whole, and that'll tell you your empirical formula. Well, if all of the carbon that used to be here is now there, we can figure out how much carbon is in this compound by figuring out how much carbon is in 1.601 grams of CO2. Okay, so that's a pretty simple problem. Let's do that first. Okay, you have 1.601 grams of CO2. Well, like most things, if you have grams, use the molar mass. If you have 44 grams of CO2, how much carbon's in there? Well, if this is 1 mole, then you would have 1 mole of carbon in it. Well, what's the molar mass of carbon? 12. So stick 12 in there. This is a ratio that tells you for every 1 mole of CO2 that weighs 44 grams, you would have 12 grams of carbon. That's the molar mass of the CO2. That's the molar mass of the carbon. Okay. That'll cancel, and now we should have our mass of our carbon. Before I grab the calculator, let's do the same thing with this guy. All of the hydrogen that used to be here is now there. So we can figure out how much hydrogen was here by figuring out how much hydrogen is in the 0.437 grams of water. So let's do the hydrogen. We're going to pull the mass of the hydrogen out of there. Well, the water weighs 0.437 grams. And what's the molar mass of water? 16, 17, 18. Okay, now how much hydrogen's in that water? 2 moles, right? Well, each 1 mole of hydrogen weighs 1 gram, so 2 moles would be 2 grams. That's the weight of hydrogen in 1 mole of water. Okay, now let's get a calculator. Okay, so I have 1.601 grams of CO2 times 12 divided by 44. Let's try to keep at least 3 significant digits here. So for the carbon, we have 0.437 grams of carbon. Now you hope it's less than the weight of the CO2, which of course it is, 0.437. Let's do the same thing here. 0.437, that's weird, they're the same, times 2, divided by 18, 0.0486 grams of hydrogen. Okay, now the oxygen. Well, all of the oxygen that's here isn't necessarily in these guys, because in order to get this to burn, you had to add oxygen. So there's more oxygen over here than was in this original compound. But here's the thing, you've done problems like this before. If that's the weight of the whole piece, that's how much carbon is in there, and that's how much hydrogen is in there. Take this value, subtract out the carbon, subtract out the hydrogen, that'll tell you how much oxygen is in here. It's the remainder. So we have to know the grams of carbon, hydrogen, and oxygen in here. We found the carbon by pulling it out of the CO2. We found the hydrogen by pulling it out of the water using molar masses. To find the oxygen, we're going to take the total weight and subtract out the amount that's carbon and the amount that's hydrogen, and what is left is your oxygen. .068 minus 0.437 minus 0.0486, 0.582 grams of oxygen. Okay, at this point, you're armed with everything you need in order to finish this problem out. At this point, it's like every other empirical formula problem that you've done. You know your grams of each piece in here, and you can figure out what the empirical formula of that is. Let's do that step next. Okay, let's find the empirical formula of this. Like any empirical formula problem, we're going to take the grams of each substance, turn it to moles. Using the molar mass of carbon. Hydrogen's, of course, super easy. Oxygen's molar mass is 16. Try to keep 3 significant digits again. .0364, that's moles now. This is the same. You guys are going to be as fast as I am doing this. What's the next step? Divide by smallest. Hey, that's convenient. Don't overround. Remember, that's where you get in trouble, because you can't see what the ratio is. I got 1.3. What should we multiply by? Yep, 3. There's 3 carbons. 4 hydrogens. 3 oxygens. Okay, so the empirical formula must be C3H4O3. Feels like you ought to be done by this point, doesn't it? But wait a minute. We don't know if that's the real formula or not. Remember, we've got to compare it to the molar mass of the actual formula, the molecular formula. So I'm going to erase part of this board, and then I'll finish it. You finished up with your empirical formula here. Now, the problem says that the real molar mass of this stuff is 176.1 grams per mole. Well, how does that compare with that empirical formula? Let's try it. All right, 16 times 3 plus 12 times 3 plus 4 for the hydrogens. The empirical has a molar mass of 88. If the real molar mass is 176, divide them if you can't see what the ratio is. Let's just see how close we are. 2. So the actual formula is twice as big, same ratio. So the molecular formula is C6H8O6. That, my friends, is about the toughest empirical formula problem that you're going to see. Now, if you got stuck someplace, or I lost you someplace, back up the video, okay? The big idea here is you get your grams of carbon, hydrogen, and oxygen out of here by pulling the carbon out of this, pull the amount of hydrogen out of here, take your total mass, subtract out the amount of carbon, subtract out the amount that's hydrogen, and what's left will be your oxygen. Then you'll have grams of carbon, hydrogen, and oxygen. That's exactly what you need to do any empirical formula problem. Well, hopefully that wasn't too confusing, and we'll see if any of that sticks in your head. I've left 2 practice problems for you guys to try to do, and if you get stuck, you can always go back and watch a chunk of the video again. And my hope is that I'll have this loaded onto YouTube sometime on Wednesday, and so I'll leave my YouTube address for the video with my sub, and right now YouTube won't let me load anything, so we'll see if they're up and operational tomorrow. Try the 2 practice problems, and I'll see you guys on Monday. Have a super weekend. Go Eagles. We can't go down against South tonight, okay? All right. Have a good one.